Resume recording. Let's take a look at this systems of equations work we're going to be looking at today. Okay, so systems of equations. We're going to be learning about this idea, this concept today, and we're going to be looking at two different systems of equations, and we're going to be solving them. So before we get started here, I want to take a look at our results yesterday from watching our Edpuzzle videos. Okay, we had 13 out of 19 students watch our Edpuzzles yesterday. So I'm going to say I'm impressed because it seems like it's higher than the other day. But what do you think? What does this mean to you? When you look at this, or if you were me and you were looking at this, what would you think about this, the number of kids that didn't do the Edpuzzle yesterday? Throw it in the chat. What do you think? What do you think? Throw it in the chat, guys. What do we think? When we see this number of the 6 people that didn't, there's 6, I don't know why there's only 5 here, but there's 6 people that didn't watch the Edpuzzle yesterday. When I was looking at it this morning, I was a little bit bummed, guys, because I'm asking you to do these activities in the afternoon. I'm asking you to do these activities in the afternoon, but I'm not asking you to do them on your own, right? I'm giving you a video of me going through it with you. So I need you guys to step it up, because remember, we are a high school level course. The expectation is that you're watching all of the content that I am creating. Okay? I understand that some people might think that they have the topic down, but if you remember, all of the activities that we do in class build on one another. Each of the activities, I'm not giving you 2 activities that are testing the same thing. I am giving you that second activity is taking that information from the first activity and it's building on it. So don't think that the second activity you don't need to do it because it's just going to be the same as the first. That's not the case. That's never going to be the case. It's always going to be building, and it's always going to be something new in some sort of way. Okay, so I need you guys to watch those videos and do those activities. Because, okay, so maybe sometimes you didn't watch the video, but you did the activity. I went through everybody's slideshows that didn't watch the video, and they still hadn't done the activity. So I need you guys to step up to the level of a high school level course and watch the content that I'm creating for you and do the activities that I'm asking you to do. Because you're not going to be able, if you're only doing half of the work, the stuff that we do in our live stream, you're not going to be learning fully everything. Does everyone understand? So I honestly, like, cool, you understand, and I'm very happy that you understand after class, but everything is building. It's never the same thing twice. It's everything in a new way or adding a new piece of information. So every single afternoon activity, you should be watching those videos that I'm creating going through it, okay? And I understand that they're like 22 minutes long, but I'm going through it with you and I'm giving you all the answers. So you're never going to be left without an answer, left wondering. You're going to be given those answers, okay? So let's learn about systems of equations. Let's learn what a systems of equation is, okay? So what you need today is you need your workbook, open up to lesson number 13 or the slide deck, okay? You're also going to need a straight edge, like a ruler, or I've been using sort of the edge of my binder, something, a straight edge, and a piece of paper and a pencil and a piece of scrap paper. Okay, so our I can statements for today are: I can explain the solutions to a systems of equations in a real world context. I can explain what a systems of equation is. And I can make graphs to find an ordered pair that 2 real world situations have in common. So we're going to be looking at 2 different equations. We're going to be finding that solution, that intersection point, and we're going to be talking about it in the context of the real world. What does it mean in the context of the story? Okay? So let's take a look at these two friends that are going for a walk. Oh no, actually we're doing milkshakes first. So milkshakes. Our warm-up for today, we are looking at this activity, milkshakes. I'm giving you 2 minutes right now to work on this information about Diego and Lynn. So Lynn started with 12 ounces and drinks 1/4 of an ounce per second. Diego starts with 20 ounces and drinks 2/3 of an ounce per second. How long will it take Diego and Lynn to finish their milkshakes? So first you have to create an equation. Then you need to solve it for how long it will take them to get 0 ounces left. Once you answer those two questions, I want you to think about number 2. Okay, so you're taking 2 minutes right now to find this point when they both would have 0 ounces left in their cup. And then you're going to start to think about the graph. I'm giving you 2 minutes right now. Let's get started. So questions in the chat if you have them. We have about 20 more working seconds. Please start to find those points when Diego and Lynn would have 0 ounces left in their cup. Okay? So let's take a look. Okay? So Lynn's equation, Lynn starts with 12 ounces in her cup, right? So that's plus 12 is my y-intercept, and she drinks 1/4 of an ounce per second. So that slope is going to be a negative 1/4. So to solve it for 0, we're going to plug 0 in for y, and we are going to solve it. 0 is equal to negative 1/4 x plus 12. So we would subtract 12 from each side. We would be left with negative 12 is equal to negative 1/4 x. To cancel out that negative 1/4 x, we're going to multiply each side by the reciprocal of 1/4. The reciprocal of 1/4 is when we flip it. So we're going to multiply each side by negative 4, multiply by negative 4. Negative 4 times negative 12 gets me 48 is equal to x. So what is that going to have? It's going to say 48 what? What's my label on that going to be? 48 pickles, pickle pencils. What's it going to be? Nice job, Gwen and Kyle. It's going to be 48 seconds. Okay? Then now if we're looking at Diego, we're going to do the same thing, substitute 0 in for y. 0 is equal to negative 2/3 x plus 20. Subtract 20 from each side. We're going to say negative 20 is equal to negative 2/3 x. How do we cancel out that negative 2/3 attached to the x? We multiply by the what do we think? Nice job, Gabe. And that's called the reciprocal. Very good. We multiply by the reciprocal. The reciprocal of this would be negative 3/2. Multiplied by negative 3/2. Okay? Negative 3 times negative 20 is negative 60 over, no, positive 60 over 2, which is equal to 30. 30 what? What do we think, Sadie? What's our label going to be on this? 30?
30 seconds.
Very good. 30 seconds. So it's going to take Diego 30 seconds to drink his milkshake. It's going to take Lynn 48 seconds to drink her milkshake. Okay? So now without graphing, explain what the graphs in this situation would look like. Think about slope, intercepts, axes, labels, and units. So the slope of Lynn's was negative 1/4. The slope for Diego's was negative 2/3. The y-intercept for these each was Lynn's was 12, positive 12. Diego's was positive 20. Okay? I want you to think about who's drinking more per second. Throw it in the chat. Elliot, Diego drank his in 30 seconds. So who's drinking faster? Throw it in the chat. Oh, who drinks it? I know, isn't that crazy, Elliot? Who drinks it faster? Max, why don't you unmute and tell us how you know Diego drinks it faster?
I know Diego drinks his faster because I know 2/3 are larger than 1/4.
Very good. So the slope is larger. He's drinking more per second. Awesome job there, Max. That was perfect. So, ladies and gentlemen, we're thinking about these two friends that are drinking milkshakes. We're thinking about what their graphs are going to look like. We're going to find those positions when they have 0 ounces left in their cup. Awesome job. Let's take a look at walking on a path now. Okay? So we're looking at walking on, or passing on the trail, sorry. Passing on the trail, okay? So we're in our textbook. We're looking at activity, oh goodness, 13.2. We're almost at the end of this textbook. Passing on the trail. So you're going to need your textbook for this one because it's going to have a piece that we're going to be graphing. And it's going to be a lot easier if you graph it in your textbook, okay? So let's take a look at passing on the trail. Okay, so if you look at slide number 9 has a picture of what this description is going to tell us on the next slide. So we're going to be talking about, we're going to come back to this slide in a moment. We're going to look at this description first. So there is a hiking trail near the town where Han and Jada live that starts at a parking lot and ends at a lake. Han and Jada both decide to hike from the parking lot to the lake and back, but they start their hikes at different times. Okay, so to sum it up, they're going for a walk on a path. They start at different times. They probably are going to be walking at different speeds. Okay, that's part number 1. Now, if we look at the second paragraph here, it says, at the time Han reaches the lake and starts to turn back, Jada is 0.6 miles away from the parking lot and hiking at a constant speed of 3.2 miles per hour toward the lake. Okay, so that means when Han is at the lake and turning around to come back, Jada is 0.6 miles away from the parking lot. And she's moving at a constant rate of speed of 3.2 miles per hour. Okay, so at this snapshot in time, so how I explained the scenario last year was, so Jada and Han are on a walk, right? And then a third friend texts both of them at the same time and says to them, "Where are you?" Jada responds to that text message by saying, "I'm 0.6 miles away from the parking lot." She looks at her Fitbit. How far did she walk? 0.6 miles away from the parking lot. And Diego responds with, "I'm at the lake, turning around to come back." Okay, so it's not saying like we're starting and magically Diego is appearing at the lake. No, they've been walking for a little bit of time and somebody texted them and was like, "Where are you?" And they both responded. And that's when we're starting this situation. Okay, so Han's distance D, because we don't know what that is, D, from the parking lot can be expressed by the equation D is equal to negative 2.4T plus 48, or 4.8, sorry, I did that last time too, plus 4.8, where T represents the time in hours since he left the lake. Okay, so looking at Han's equation, what kind of slope does he have? Throw it in the chat. What kind of slope does Diego have in his, or Han have in his equation? Good, Abby? Let's see, everybody throw an answer in. What kind of slope does he have in his equation? Good, keep going, nice job. Max, take a look at that 2.4. Nice job, Max, good correction. Junior, perfect. John, what kind of slope does he have? Nice job. He has a negative slope here. If you look at it, it has a negative 2.4. So that means his equation line is going to be moving in this general direction. It's going to be moving down as you move left to right. Good. So if Diego is at the lake, or Han, why do I keep saying Diego? If Han is at the lake, how far is the lake from the parking lot? If he's at the lake and you have your y-intercept in that equation, how far is the lake from the parking lot? If I'm looking at this distance right here, how far is it? Throw it in the chat, guys. Nice job, Abby. So look in your textbook, how far, looking at that equation and knowing where Han is, how far is the lake from the parking lot? I have 3 friends that threw it in the chat. I need 6 more people to put it in the chat. How far? Nice job, Max. Nice job, Ian. Nice job, Abby. Very good, Gabe. You know what I love? I love that you added that label to it. Perfect. Okay, I have 4 friends. I need more people. How far is the lake from the parking lot? Look back at the equation here. Nice job, Ava. Nice job, Connor. Very good. So the lake, if we look, Jada is not at the lake. So the lake is not going to be 0.6 miles away. It's going to be that y-intercept on Han's equation. We know Han's slope is negative 2.4 because that's the number that's attached to our variable. And so this y-intercept is going to be how far the parking lot is from the lake. So to get from the parking lot to the lake, it is 4.8 miles. Okay. And we're not going to say 0.6 miles because 0.6 is where Jada is, but Jada's not at the lake yet. Okay, do we see why that isn't 0.6? Okay, so our Han is, so the lake is 4.8 miles away from that parking lot. So let's answer some questions about these guys. Okay, so when t is equal to 0, where is Han and where is Jada? So first in the chat, I want you to tell me when t is equal to 0 at t seconds, how far is each of these people from the parking lot? Jada and Han. So how far is Jada from the parking lot? Tell me in the chat. Nice job. Jada is 0.6 miles away from the parking lot. Okay. How far is Han from the parking lot? Throw it in the chat. Okay, what I need is, Adam, unmute. Tell me how far is Han from the parking lot? Adam, how far is Han from the parking lot at time 0?
$3.2 miles.
Well, let's think about it. We said how far is the lake from the parking lot?
0.6.
Nope, Jada is 0.6 away from the parking lot. That is Jada's position. If you look at Han's equation, that distance from the parking lot to the lake is his y-intercept. What is his y-intercept in that equation?
4.8.
4.8. So how far away is Han from the parking lot?
$2.4.
That's his rate of change. That's how fast he's walking. I need how far is he away from the parking lot? The parking lot, the lake, he's at the lake, and the lake is 4.8 miles away. So how far away from the parking lot is he?
I don't know.
4.8 miles, sweetheart. Because if you look back at the diagram has him at the start at the lake. And we decided that the lake is this distance here, this y-intercept here. So how far away from the parking lot is he? He's 4.8 miles away, that y-intercept value. Okay? Do you see that, Adam? Do you get what I'm saying now or no?
Mm-hmm.
Okay, wonderful. So let's look back. Okay, so Han is 4.8 miles away. Jada is 0.6 miles away. Okay, so for time shortly after 0, is D decreasing or increasing for Han? So is so as he's walking, is his distance increasing or decreasing? Is he getting closer to the parking lot or further away from the parking lot? Tell me in the chat, guys. As time is going on, is he getting further from the parking lot or closer to the parking lot? Okay, Gabe, why do you say Han is getting closer?
He's already at the lake and now he's heading back to the parking lot.
Boom, nice job. So Hans is decreasing because he's getting closer to the parking lot. Another reason that you can say his is decreasing is because he has a negative slope. He has a negative slope in his equation, so he's decreasing. So now, what about Jada? Is Jada, as Jada is walking, is she getting further away from the parking lot, or is she getting closer to the parking lot? Tell me in the chat. So as Jada is walking, is she getting further from the parking lot, or is she getting closer to the parking lot? Nice. Okay, Ian, unmute. Tell me why you think she's getting further away.
She's getting further away because she is walking towards the lake, which is away from, and also she has a positive slope.
Very good, because she has a positive slope. Very good. Increasing because she has a positive slope. Okay? So, number 1 is asking us to write an equation for Jada's distance from the parking lot as she heads towards the lake. So, let's do this together. When we're writing an equation, we always start with what? Throw it in the chat. What do we always start with? Y. Very good. Y equals. Very good. Okay? Now, if we think back and we look back up to the story up here, what is Jada's rate of change? Pal, what is her constant rate of change? Nice job, Connor. Oh, wait. Connor, we're going to take a second look at that. Nice job, Ian. Her rate of change, her constant speed is 3.2 miles per hour. Nice job, Junior. Fantastic. So it's going to be Y is equal to 3.2 what? (3.2x). Very good. 3.2x because that's our constant rate of speed. And we're talking about x representing the time. Very good. And then we're going to add our y-intercept. And what is our y-intercept in this story? Where did Jada start walking from? She didn't start at the lake, Kyle. Diego started at the lake. She started at 0.6 miles. Awesome job, ladies and gentlemen. 0.6. Because at that time when the friend sent the text message, if we look back, Jada was already 0.6 away from that parking lot. So her y-intercept is going to be 0.6. Okay? So now, no, it's not a big deal, not a big deal. You don't even need to say my bad because we're learning. This is new learning, okay? So now, make sure that you have this equation written down because I'm going to be erasing it and we're going to be looking at the next page here in your text where you're going to be graphing these two equations. So I'm going to put my pen down, I'm going to scroll a little bit, and let's take a look at this piece right here. Okay, so we have 3 more questions that we're going to be answering here after we create this graph. So what I'm going to do is I have my 2 equations, which I'm going to write in a moment. I'm going to open up this so that I can graph my story because I don't have like stacks of cups. We're here, okay? So we have our 2 equations. If we remember, Hans was y is equal to, oh goodness, negative 2.4x plus 4.8, and Jada's is equal to y is equal to 3.2x plus 0.6. So now your job in your textbook is to graph this situation, each one of these equations. Remember, when we are graphing equations, first we plot our y-intercept, and then we use our slope to continue out our line. So what I want you to do is I want you to take 3 minutes right now to plot these 2 equations, Han and Jada, in your textbook. If you don't have a textbook, you need to do it on this app right here. You're taking 2 minutes right now to, in your textbook, create this equation. Let's get started. Or graph these two equations, I'm sorry. So we're going up, by the way, if you look at this, we're going up by 0.2 on this grid here. So 4, 4.2, 4.4, 4.6, 4.8. Okay. And then for every 1, we're going down 2.4. So 1, 2.12. Oh, I need to go one more. Okay, let's take a look. Okay, so for each of these equations, you first had to plot your y-intercept. X plus, or 0.6, yes. So I plotted my two intercepts at 4.8 and 0.6. Okay, and then I had to plug in for example, I just plugged in 1 into each of these equations for X to solve for my Y. So when I plug this in, I get 3.2 plus 0.6 is equal to Y. So Y is equal to 3.8. I'm sorry, wait, let me try that again. So 3.8. So Jada, if I come to Jada's line, I need to go over to the 1, up to the 3.8, which I put a point right here. Then I had to solve Han. So then I connected my points to create my line. Then for Han, I did the same thing and I plugged in 1 for X again, negative 2.4 plus 4.8. When you add those together, you get 2.4. Positive 2.4 is equal to Y. So Han's point at 1 hour would be at 2.4. And I put a point here. And I connected my y-intercept with that point at 2.4. Do you guys see how I did that? Make corrections to your graph. If your graph does not look like, actually, I'm going to erase these lines because I want you to be able to see it. Make changes to your graph if yours do not look like mine, please. Okay. So I have this graph right here. I'm going to print screen and I'm going to insert it into my slideshow so that we can use it to answer. Oh no, come on, Mr. Main. And we're going to use this graph now to answer some questions here. So I'm going to close this out, make it a little bit bigger, and let's answer some questions here, okay? So we're using this graph to answer some questions here. Find find the point where the two graphs intersect each other. What is the coordinate of this point? Throw it in the chat. What's the coordinate of our intersection point? Making sure you're putting it in coordinate form. X comma Y in parentheses. Over comma up, not up comma over. Very good. Nice correction, Kyle. So let's find out where that intersection point is. That is right here. That point where our two lines cross. I need to look at my scale now. How many do I have to go over? 0.25, 0.5, 0.75. So it's going to be 0.75, comma. How many do I need to go up? If I grab this point and I carry it over to my y-axis, it hits at the number 3. So my coordinate for that intersection point is going to be 0.75, comma 3, or 75 hundredths, comma 3, making sure that you put them in parentheses, okay? What do the coordinates mean in this situation? In the context of this story, what does this point mean? Let's see. Let's see. I want to hear from somebody I haven't heard from yet. Abby, can you unmute and can you tell me what this point means in the context of our story?
It means where they both meet, like when they're walking on the path.
Okay, but what does that 0.75 represent? Hours, pickles, what?
Wouldn't it be miles?
Well, look at the label on that axis where the 0.75 is.
So it would be hours.
So it would be after 0.75 hours. What? After 0.75 hours, what do? They
Walk 3 miles.
They walk 3 miles, but they're not walking 3 miles each. They're meeting at 3 what? What does that 3 represent?
3 miles.
3 miles away from the,
Lake.
not the lake. We're always looking at it in regards to the
Parking lot.
parking lot. So after 0.75 hours or 45 minutes, they will meet three miles away from the parking lot. Okay, you need to make sure that we're understanding the context of that point. So X represents time, and the Y represents the distance from the parking lot. Because if we're talking about the total distance that they walk, both of them would be walking a positive slope here. We're not talking about the total distance that they've walked. We're talking about the distance from the parking lot. So after 0.75 hours, they will both be 3 miles away from the parking lot. Okay? So ladies and gentlemen, what I need from you today to close off today, we're not done with this yet, but to close off for today, please don't leave. Okay? So what I need for you on slide number 12, every single person needs to do this. Take a picture of your graph from this activity and you need to insert it in on this slide. Take a picture with your camera, take a picture with your phone and insert it here on this slide. Okay? That's step number 1. Then I want you to look at this slide number 14 that talks about the systems of equations. I want you to read through it. We're going to discuss the definition tomorrow. And then the link to the videos for the second half is on slide number 16. I'm once again going to be putting in grades for the percent of the video that you watch. So you need to watch the whole thing and do all of the activities. It is not the same thing that we did this morning. It is a different type of skill that you're going to be working with. So everybody needs to do it, even if you feel like you completely understood this morning's activity. Does everyone understand that? Throw it in the chat, please. I need to hear that you understand that you need to watch this video. It is not something that we've already done. It is a new sort of piece of learning here. Okay? So please make sure that you are completing the second activity here. And you are looking over this definition of systems of equations. We're going to be reviewing systems of equations tomorrow. And we're going to be looking at and reviewing this activity before we get started with a new one, okay? So have a good afternoon. If you have questions about anything for today, please reach out to me through email and I can answer you before the end of the day today. Okay? You need to, Max, I want you to stay for a minute. I need to talk to you. Everybody else can head out. Hi, Max. So I'm assuming you saw my email. Let me just stop.